Hello, everyone, and welcome to the Geek Night podcast. I am your host, Kaivalya Apte, and I am back with another episode and a very interesting topic. So, today's topic is tiered storage, and we will understand what do we mean by tiered storage, what kind of systems need tiered storage, and mainly how Apache Pinot has implemented tiered storage. And for doing that, I have Neha Pawar with me, who is one of the founding engineers at StarTree. StarTree, which is the company behind Apache Pinot, which powers Apache Pinot and all the cool feature it has. So, welcome, Neha Pawar. I'm really excited to have you here. And thanks a lot for joining.
Oh, my absolute pleasure. Thanks a lot for having me here. Super excited to be here. I've been listening to some of your podcasts and you're doing amazing work. So it's very nice that I'm getting an opportunity to be here with you.
Awesome, awesome. Yeah, let's start with a brief introduction about yourself for our viewers, and what you're currently working on. How did you end up in software engineering and at StarTree? Some stories behind that. Would love to know that.
Cool. Um, so currently, so my name is Neha. Currently, I'm working at StarTree, as Kaivalya already said. So I joined StarTree about 2.5 years ago. And prior to that, I was working at LinkedIn, where I started off working in this team called Third Eye, which was Third Eye is like this root cause analysis and anomaly detection tool. And it was like a pretty powerful, pretty great tool to kind of monitor the anomalies in key business metrics that were important to LinkedIn.
Hmm.
And while working on that, so at that time, Third Eye was built on top of Pinot. So it still is, but now there's like many more sources that you can plug in beyond Pinot.
Yeah.
And I used to always be like super intrigued that, hey, all these, like we're trying to fire queries that have a lot of point lookups and a lot
Hmm.
of group bys and a lot of drill down and roll up and everything's like, what is this backend that's just like returning everything like super fast? So I was really intrigued. That's when I found out that it was Pinot and uh, kind of decided that, oh, that's where I want to work next, and been working on Pinot since then. Started
Awesome.
working a little bit initially on the real-time ingestion part, making real-time ingestion pluggable, solving challenges in scale in real-time ingestion. Then worked a little bit on the query engine side, uh, worked on adding some query constructs, which like around 5 years ago, uh, we used to be on a very limited subset of SQL, and now we're getting closer and closer to that.
Hmm.
So worked a little bit on that. Most recently, been working on the storage side, storage optimization, bringing the cost down. So the tiered storage project for Apache Pinot.
Yeah.
So yeah, that's what I am mostly up to these days.
Awesome, awesome. Yeah, it's really cool to hear, the projects that you've worked on and the challenges you have solved. So I'm really excited that we are talking about, tiered storage because storage cost and optimizations around that is a really challenging problem to solve. And I'm really interested in knowing how Pinot is able to do it. So for the viewers, we are going to talk about tiered storage. We are going to drill down into, what are the implementation options, what are the general solutions other technologies have, and how Apache Pinot has done it and how it differs from other solutions. So great, let's start with the basics as we typically do. What do we mean by tiered storage?
Cool. So tiered storage, as like let's just take the term as it is. Now there's two words in it, tiered and storage. So let's kind of look at each one separately. So storage is something we all know. Storage is something where we store data. It can be the RAM or disk or SSD or a blob storage or even tape drives.
Yeah.
And then all of these have like different characteristics and specs.
Hmm.
Example, they can have different write speeds, read speeds, the cost per data unit.
Yeah.
They could be volatile, non-volatile. So tiered storage is nothing but a single application that is able to use these different types of storage. And not just being able to use the different types, but also being able to use them in a very configurable manner.
Hmm.
So be it like a streaming infrasystem or an analytics infrasystem or an object store.
Yeah.
So, for example, in the same data set, you might have data which is accessed less frequently because, say, it is much older, or data that you're okay accessing slightly slower because it serves some non-critical use case. Or
Yeah.
let's say you have some very popular key which you want to serve with the lowest latency. So,
Mm.
being able to use the same system and use different storage such that the return on investment you get for these is justified, and
Mm.
also the performance that you need for the different types of storage that you have, the different types of data that you have, is justified.
Yeah, yeah, I think that makes a lot of sense because ultimately we want to optimize our storage because that is also costly. And in systems that have lots and lots of data and like coming in at a very high pace, I think that becomes even more important, right? So before we jump into that, I wanted to ask you, like, typically how many tiers are there? Like, are there like multiple tiers, or there are just three or four, or how many tiers do we talk about generally?
So most typically there are like systems that fall in two categories broadly. The ones that use just disks or SSDs, and we kind of
Hmm.
call them tightly coupled systems. And then the ones that use cloud object storage, and we
Yeah.
kind of call them decoupled systems. And uh, so, most interesting use case for tiered storage is when you're able to combine these two,
Yeah.
because they are very different in terms of the cost that you pay for them, and also in terms of the performance characteristics.
Hmm.
And with that comes the challenges that, oh, you are combining these two and you're able to maybe reduce the cost, but then you don't really want to lose out on performance. So these are kind of like the typical interesting two that you combine.
Yeah.
But there are also use cases where you might want to just have multiple disks of varying specs or
Hmm.
varying performance characteristics in your systems. You still keep it tightly coupled, but have tiers in that also.
Okay. Yeah, I think that makes sense, and I think as per my limited understanding and experience with these systems, I've also seen these are the like primary ones that people talk about because that's most like highly available. Uh, Great. I mean, I think you talked about two parts. One is definitely uh, how to implement the tiered storage, like how do we maintain these two types of storage devices and, provide like a unified API such that it is abstracted out or abstracted away from the customer who is making that query or using the system. So we are going to cover those in detail in coming sections. But I just wanted to ask you, is it mainly about cost optimization when we talk about tiered storage? And how do I know that, how do I compare the cost of, storage that I'm saving versus the performance hit I might have?
Right. So to start off with the first part of your question, that is it mainly about cost optimization? So no, it is cost is certainly one of the main aspects, but
Yeah.
there are so I like to call out three major aspects here. So and this is like broadly, this is beyond just Pinot. It's like whenever
Hmm.
you're building and operating infra, the three considerations on top of mind are usually cost, performance, and flexibility.
Okay.
And tiered storage kind of helps you think about all of these and
Hmm.
helps you kind of navigate all of these in your system. So to kind of like explain more about that, I wanted to kind of drill down more into the tightly coupled and decoupled that we talked about a little bit earlier.
Yeah.
So, and I guess I'll talk about this with respect to analytics infra, since
Yeah.
that's what I'm closely familiar with.
Yeah.
So then we have these tightly coupled systems. So your systems like Pinot, which it used to be, and then ClickHouse, Druid. So in these, the storage is tightly coupled with the compute. So
Hmm.
compute nodes use like disk or SSD, which can be local storage or some remote attached storage like EBS volumes.
Yeah.
Now, these storage, these types of storage have some amazing access latencies
Yeah.
because you have You can use like POSIX APIs, you can do fancy techniques like mapping your data. So accessing your data from like a local storage is usually microseconds, and from some remote attached volume is like
Hmm.
milliseconds.
Okay.
So example, Pinot, which used to be strictly tightly coupled, and you still can operate it in tightly coupled mode. It was like these systems tend to be amazing for ultra low latency, high throughput analytics in
Hmm.
analytics infra. So you can like use them for things like real-time analytics, user-facing analytics. So great so far, but then the problem started happening when like Pinot got really popular, and Pinot people wanted to store more and more data in Pinot,
Yeah.
not just use it for user-facing or real-time analytics, but they're like, oh, we have this system, we have this cluster already, we want to use it for ad hoc analytics, we want to
Hmm.
use it for internal dashboarding, reporting use cases.
Yeah.
Uh, and of course, you can do that, but as your data volume keeps increasing in such systems, the storage can get like super expensive.
Hmm.
And also, another challenge here is that if your data volume is increasing, you typically have to end up adding storage plus compute units. You can't just keep expanding the storage.
Yeah.
So very often, just because your data volume increased, you are paying for a lot of compute, which is going to be underutilized.
Hmm. That makes
So
sense.
if you need it all very fast and your business is like it's justifying the business value that you are getting, all good. But most typically, that's not the case because all data is not equal.
Yeah.
So real-time data, the recent data is like queried more, used for like user-facing end user products. So you're kind of okay paying more to serve that data.
Hmm.
The historical data is also very important, but you're typically it's queried less frequently, and also you're okay with slightly higher latencies.
Yeah.
So people were asking us that, hey, can we somehow tune Pinot to bring the cost down a little bit with some trade-off in performance?
Yeah.
So previously this was not possible. It was like
Hmm.
strictly tightly coupled. And then, so the other option for people was to try out this other category of analytics infra called decoupled systems. So these are the systems like Presto. And here the storage is decoupled. So you
Yeah.
have compute only nodes, and then you use some cheap object store like S3 to keep the data. And whenever you need to access that data, uh, you don't have the POSIX APIs, you are going to have to make a network call.
Hmm.
So naturally, you're not going to get microseconds, milliseconds latency. Your
Yeah.
latency is now going to enter into the seconds range,
Yeah.
which means you can't use this for real-time analytics.
Okay.
So with this, your cost is better, but you're taking a hit on performance. So the solution so far for people mostly used to be that add both these systems, keep the recent data in the tightly coupled system, keep the historical in the decoupled system. But uh, you're kind of now you've lost out on the flexibility aspect
Yeah.
because you have to maintain multiple systems. You probably need like a federation layer where you have to decide where to send your query.
Yeah.
It's also kind of limited in configuration options because every time you have to move data from, say, one system to other, it's not going to be like very easy. You'll have to kind of involve some data ingestion pipelines, data movement pipelines. So these are kind of the three aspects that tiered storage helps with,
Hmm.
because tiered storage is kind of like building a best of both worlds, like a true best of both worlds, not just combining them,
Not
but
just, yeah.
having one system where you can serve all of this,
Okay.
like get all of these benefits, get all of these, like able to choose your exact trade-off in all three of these aspects.
Okay. I think that makes a lot of sense, and you covered some of the great points. And thanks for explaining that in such a simple manner. Because so the first thing we talked about was the tightly coupled, and tightly coupled we mean the compute and the storage is tightly coupled, as in they are on the same machine, right? Uh, is that right? In if we say it in simplistic word like that, or
It is right if you can imagine it that way, certainly.
Yeah.
But usually when you have like an EBS volume, it's not on the same
Ah.
machine, but you can sort of access it as if
Yeah.
like you can use like the file API and you can
Hmm.
access it directly.
Okay.
And that kind of makes all the difference between
Hmm.
uh, that versus like making a network call to kind of get an object from S3.
Yeah. Yeah, I think that makes sense. You also mentioned something like, so one is that you can use POSIX API if you have like local storage, and also you can do M mapping. Can you shed some light on what is M mapping, and how does it work?
So this is a technique that's used a lot by OLAP systems. So
Hmm.
you kind of take your files are on disk and then you kind of map them onto the memory
Hmm.
and you let the operating system take care of moving them in and out, kind of working set,
Okay.
uh, keeping the working set up to date so you don't have to bother about it. And now if you combine this with something like an SSD where the swapping in and out is pretty fast,
Hmm.
then you kind of have sort of you're not limited to just the RAM that is available on your machine. You
Yeah.
can take it as far as the disk that you have attached. So
Okay.
that's kind of like a way to access more than how much memory you have in a fast manner in OLAP systems.
Yeah, very interesting. So I think I read about it a while ago while I was working with Pinot, but I think that's very interesting to know, and I'm more interested in learning how it works. So I'll definitely do that. So I think we have set the basic context about what is tiered storage, how does it work, what are the typical types of systems we have when we talk about storage system. Let's dive deeper into the implementation details about. So let's say I, as a developer, I'm working on a system. I have a storage system, and I want to split that storage into multiple tiers, and do that in a way such that it is not or it is abstracted away from the consumers, and with the flexibility like we have for modern tiered storage systems. So how do I approach that at a high level, and what kind of challenges or things should I keep in mind to make it more optimized and more performant?
Mhm. Right. So your most basic option would be to just go with the approach that we talked about of having, say, two systems. That's kind of the simplest way to get
Yeah.
started, where you'll have a system like Pinot for the real-time part, and then all your historical data in something like Presto. But we also talked about how this is kind of not the best solution because of like the query federation, the limitations in configuration,
Yeah.
operational overhead, and so on. The other kind of popular approach that we've seen in many systems,
Mm-hmm.
it's called lazy loading.
Hmm.
So in lazy loading, it's like you have kind of offloaded all your storage away from the tightly coupled to some cloud object store like an S3. And when you need to access that data, so let's say it's like an analytics database. When you get a query and then your compute realizes that, oh, I need some shard of data that's somewhere in S3,
Yeah.
then it will fetch it and then it will cache it locally.
Okay.
So with this, your first query is always going to be slow because you're
Hmm.
fetching like an entire shards of data that the query needs. Like think of it that in cold start, you kind of have nothing. So you're fetching
Hmm.
everything that the query needs
Yeah.
locally. But then the hope is that the next query that comes in will be able to reuse a lot of this data. So it'll be
Yeah.
very fast.
Yeah.
And this approach seems to work pretty well for streaming systems.
Mm-hmm.
Like I think Red Panda has done an approach like this. But in these systems, the access patterns tend to be more predictable.
Hmm.
So you're kind of like read from a topic, you're just like reading
Yeah.
uh, all of it sequentially. But for OLAP systems, this is not a very great idea because in like typical analytical queries, you'll have like shards or segments that like that's what we tend to call it in Pinot.
Yeah.
So the segments accessed by the query will like be very different and all over the place often. So, for example, it can be different time ranges or different user IDs data that you're trying to fetch. Uh, so if we kind of download on the first access and cache it locally, very
Mm.
likely we have to remove the segments and download all over again for the next query. Or even
Ah.
worse, sometimes within the same query, you might have to kind of download, trash it, fetch the next batch because you might have to fetch a large volume of data,
Yeah.
more than what your cache allows you to store within
Yeah.
the context of the same query.
Hmm.
So this is like lots of downloads, lots of churns. It's very bad if you want predictable query latency or if you want to have like a good P99 latency.
Hmm.
So this is kind of one popular approach. Uh, and then there's the approach that we decided to take in Apache Pinot. So in this, we kind of kept the tightly coupled part as it is. And now we have some configuration that lets the user decide that, hey, I want to keep this portion of my data in tightly coupled mode. The rest, I want to keep it in decoupled mode. And then Pinot under the hood is going to keep moving all that data and making sure it's in the right place
Mm-hmm.
automatically. And to access the data on the decoupled storage on the Cloud Object Store, we decided to not do any lazy loading and not rely on caching. We kind of started to think about how can we improve the worst case. So
Hmm.
assume that the query has to read data from the remote segments. So let's not rely on like caching and all that. It's just going to be optimizations on top of this.
Hmm.
But let's make sure that the basic design itself is able to optimize for reading from like the basic design itself is such that we have optimized for the worst case.
Okay.
So kind of directly be able to fetch from S3, execute it, and let it go.
Yeah.
And that is how we can kind of guarantee consistent and predictable low latency for all queries. And then in Pinot, we are also able to, like once you've done this, once you've set up your cluster to have like some data here, some data in remote, you're able to query all of it seamlessly as if it
Hmm.
was the same table. You're kind of not going to um, know the impact of it being on different types of storage.
Okay.
So this is kind of roughly the approach that
Yeah.
Pinot took.
Okay, okay. For our viewers who are not really aware of what Apache Pinot is, uh, so let's define what is Apache Pinot. So what I understand, so Apache Pinot is this OLAP data store for low latency, high scale real time analytics, which has servers which store the data and make the query processing and gives you back a result, and then since it is high scale and like data intensive system, we need tiered storage, and I think that's what it is, right? Do you want to add more on that simplistic definition that I mentioned?
Oh no, you summed it up perfectly. I guess one thing that I would add is just kind of define some exactly or define exactly what the low latency high throughput
Yeah.
means.
Yeah.
For example, like low latency is subjective. Like you could have a system that serves data in seconds
Yeah.
and still say it is low latency compared to something that serves in hours.
Makes
But when
sense.
we say low latency in Pinot, we mean
Mm-hmm.
like milliseconds latency.
Yeah.
So for example, we have a cluster at LinkedIn that is able to keep milliseconds latency SLAs with 250,000 queries per second. So it's kind of serving all of LinkedIn's end user facing analytics. So this is kind of where Pinot shines
Okay.
because of the ultra low latency, high throughput nature of it. It's like an excellent choice if you want to take all your massive data,
Mm.
build a product, and then directly give it to end users like you and me. So
Yeah.
people using an app like Uber Eats, or if you're trying to slice and dice into your profile views on LinkedIn and so on.
Mm. Yeah, that makes sense. And like for viewers who are, who don't know a lot about Pinot, I would really encourage them to, look at Pinot's architecture, how things work, maybe just try it out. and reach out to folks from StarTree or Pinot if you're really interested, because I find it very like beautifully crafted system, because the way it works, I have limited understanding or knowledge about it, but I tested it and compared it with some other tools, and I found it very insightful. So please do that. uh, I think we talked about a bit, you know, at a high level, what were the challenges that we wanted to, uh, you know, think about while we are implementing tiered storage. Uh, so I think you also mentioned briefly about how Pinot is not doing the lazy loading approach, which is done by some other
Yeah,
systems. So can we go a little deeper into, how it is exactly done? So when we say we are not doing lazy loading, then how it is done? How is it working?
yeah, absolutely. Happy to go into the details of that. Uh, so we said that, so I mentioned that Pinot used to be strictly tightly coupled, and now it's not anymore. You can have multiple tiers, not just, uh, so I mean, this is the more interesting case with like some tightly coupled, some decoupled, but you can also have something like multiple disks, and
Yeah.
like there's a bunch of ways to configure it. Uh, but then the challenges and in the implementation come mainly when you think about the tier of accessing from the cloud object storage, like an
Yeah.
S3.
Yeah.
So the first part was just decoupling storage from compute.
Mm-hmm.
And then the second part was to making sure we keep the speed of Pinot when we're doing that.
Okay.
So decoupling storage from compute for reducing cost.
Mm-hmm.
And the second consideration was that the query should still be able to run regardless of where it is. So
Mm.
not like in systems that do caching or lazy loading, eventually your segment comes back onto the local disk.
Yeah.
So then you kind of your query access doesn't have to change. It's kind of
Yeah.
it's like you've just gotten it and everything should just work. All you had to
Yeah.
do was fetch it at the right time.
Yeah.
But that was like when we decoupled it, we wanted to make sure that hey, wherever it is, it should continue to run from there.
Hmm. Okay.
And we're not going to have the luxury of pulling that whole Pinot segment onto the local.
Yeah.
And that was one of the problems because Pinot segment, like the query engine, assumed that the Pinot segment is local. So we were always using SSDs or EBS. And when the queries executed, they were just looking for the segments locally. And
Hmm.
because of that, it was like super fast.
Yeah.
But now we had like put those segments onto S3. So
Hmm.
we had to create an abstraction in Pinot for the
Yeah.
file system to
Hmm.
hide that away
Yeah.
and make it agnostic, make Pinot agnostic to where the segment was.
Mm-hmm.
And in the process, we kind of had to correct a lot of assumptions because a system that has been assuming, making one assumption and never thought that this assumption would change. And then now suddenly we were like, no, this is now a new abstraction that the system has to work with.
Yeah.
So that was the first part. And with that, like separation of storage and compute was done. And after this, the query worked, but in kind of like our initial testing, we kind of ran quick start and like a simple select star, 10 rows was taking like 50 seconds. So this was like definitely not something that we could
Yeah.
boast about. So then we got to the second part, which was the more challenging part of
Mm-hmm.
making it fast.
Hmm.
So making sure we're still able to use this for user-facing low latency analytics. So the questions that we were thinking about here were, so now the data is on S3, let's say.
Yeah.
So when do we read and what all do we read when we need to access some data segment?
Okay.
So we decided to take like a closer look at the segment processing in Pinot.
Mm-hmm.
So Pinot queries run incredibly fast when segment is on local. In
Mm-hmm.
this mode, the fetching of the data is combined with the processing in the same thread because reading data is just so fast when it's
Yeah.
on local.
Yeah.
But when it's on S3 and if you access like several segments, each access from S3 adds around hundreds of milliseconds to the segment processing.
Hmm.
So one of the key observations that we made was in case of a remote read, the CPU is idling when the data is being fetched. So let's
Hmm.
say if you have to read 100 segments and you're paying a S3 round trip time for every each of the 100 segments, your latency is going to be 100 times.
Yeah.
So in Pinot, we're not actually going to process each segment one by one. We
Mm-hmm.
will, there is like a parallelism factor. So let's say that that factor was 20 threads. So we're going to process 20 threads at a time.
Mm-hmm.
But even then, if each batch was taking, say, 100 milliseconds, you're kind of
Yeah.
adding 500 milliseconds to your query, like right there.
Yeah.
So we made changes to the query layer to just decouple this fetching part from the processing part
Hmm.
so that we could fetch as much as possible for the scope of one query in one shot. We
Okay.
kind of call this prefetch, so we can
Hmm.
like kickstart the fetch for all the segments in like the planning phase,
Mm-hmm.
so that when the batches start executing one by one in the execution phase,
Hmm.
if resources were available, you kind of just have everything ready for that query uh, then and there. And then the second part is, like I just said, if resources were available. So resources are limited on the compute nodes. So unlike a lazy loading approach where you kind of have to download the whole shard or the segment,
Yeah.
we decided to make use of the columnar storage format in Pinot.
Yeah.
So with that, we were able to fetch only the columns and indexes required by that query. So
Okay.
if you have 100 columns and you're just doing select one column group by another column, you don't really need to fetch all the 100 columns. So we were
Mm-hmm.
able to make use of the ranged get query in S3
Hmm.
to only fetch the portions, the specific columns that we care about for that query. And then we were also able to fetch the indexes from for those columns. So with that, like with those indexes and with just those columns fetched, uh, we kind of then used it for the execution, and our initial results kind of showed that with this approach, we were able to get like a much better performance than if you would have used like a Presto, for instance.
Hmm. Okay.
So we're kind of able to get 5x to 10x times faster, uh, mainly because of these two techniques, because of all the prefetching and because we're able to use the indexing even though it is on S3.
Okay. Those are so many interesting points. I just want to validate my understanding. I want to summarize in my words, and then you can say that did I miss something or not. So, what I have is I have some hot storage, which is still on my machine, and then I have S3. And when I make a query, let's say my query spans across these two storages. So hot storage, like reading SSDs, and some keys are in, let's say, S3. uh, Now what Pinot did, instead of, so first thing was, instead of uh, like pulling one batch and processing it, it separated the, fetching and processing part, so that when processing actually happens, so when I say processing, it's query processing, all the data is already there, right? And then it's somewhat brought the same problem that lazy loading had, which is, if we pull in a lot of data, the entire segments of data, then you might not have resources, and it is again going to spike the cost. So for that, what you did was using the power of columnar storage, which is just pulling in the columns that I am interested in as part of the queries, right?
Yes,
Did I miss
you
something?
summed it up perfectly. No, that's right.
Awesome, awesome. Yeah, these are very interesting techniques. And uh, correct me if I'm wrong, but Pinot was Pinot already using or always using the columnar format, if I remember correctly, or this was
Yes.
changed recently?
No, so from day one, it was designed with columnar format in mind, which is sort of typical for OLAP systems, and that's kind of helps uh, even even when you're accessing segments locally, you're kind of able to quickly access the columns, the sec indexes of those columns. So it was always designed as a columnar
Yeah,
store.
nice. So as always in software engineering, there is some trade-off that you have to make, and these little optimizations. I mean, it may sound little optimizations, but when you had to implement it, there might have been, so many different challenges that you would have solved. So really, kudos to the team on solving that. It gives a nice pattern and nice learnings uh, from a system like Pinot, that separating concerns like processing and query processing and fetching the data, it can really help clear out some of the things. And first of all, I think the challenging part was to create this abstraction layer, because Pinot always assumed that data is going to be there locally. So yeah, I can imagine all the challenges. uh, let's talk
Yeah, that's
about.
a very interesting point you brought up because we always tend to focus on, like, say, hey, cost or like flexibility or performance.
Yeah.
But just the mere fact that, hey, this was not possible, and
Hmm.
now this is possible in a tightly coupled system where you are able to just use the same system. You don't have to worry about the cost anymore. You don't have to worry about running out of space. Uh, you can kind of scale your compute and storage
Hmm.
independent of each other. So just making that was not possible now possible is
Yeah.
one part that's also really exciting.
Yeah, that makes a lot of sense. uh, So I just have one question out of curiosity. So since we are just fetching the columns that we are interested into, so we make it faster and we make it more resource optimized. Uh, what happens if I just query for all the columns? I mean, is it expected that it will work not so well, or do you do some more optimizations there as well?
So that's a great question. So we were already fetching lesser than what than, like, say, the whole segment. So we
Hmm.
kind of already had made a little progress into a more optimized version than most other systems were doing.
Yeah.
Uh, but when we, like I mentioned, that we did some benchmarking with and compared with like a Presto, and we were kind of 5x, 10x faster.
Yeah.
But we were still, we also kind of took a baseline with Pinot in fully tightly coupled mode,
Hmm.
and we were still kind of much slower than that, which is expected. You're kind
Hmm.
of now adding like network calls, and there's
Yeah.
there's no magic to kind of avoid that.
Yeah.
But we were slower than, like, we were not happy with it. We were kind of, it was slower than what we thought is acceptable to kind of ship to our customers. Uh, so one of so we kind of decided to do like this stress testing to figure out like more interesting patterns, to see where are the bottlenecks, what
Hmm.
are the things that are holding us back, to find edge cases like the ones you mentioned, that, hey, you're fetching column now, but what if I just like, what if my query is just like fetching everything? Then you're kind of
Yeah.
back to square one, and that's a great point. So in our testing, we kind of got a few more observations, very interesting ones that helped us come up with more optimizations. Some of these are still in progress, some of these are in kind of POC phase, but I'm like happy to share and talk about them. So one of the observations for us was that as the data size fetched increased, either because of large columns or too many columns, we started seeing that the network was easily saturated.
Hmm.
So all the instances that we used, they
Yeah.
have a fixed network bandwidth. So like in our testing, the ones we were using had 1.25 gigabytes per second.
Hmm.
So no matter what we did, no matter how much parallelism we increased, or how
Yeah.
many like the query worker parallelism and number of segments we read in parallel, if one batch or if the prefetch was trying to fetch more than 1.25 gigabytes per second, we're like saturated, and none of these optimizations are working anymore. So we are reading less, but so that got us thinking that, can we read even more less?
Hmm.
Do we really need to fetch the whole column, or is there a way for us to go even finer there?
Yeah.
And then the second observation for us was, if the network was not saturated, like if we were able to apply some techniques and not fetch the whole column but read like lesser within each column, uh, then increasing the parallelism was kind of helping a lot, which kind
Yeah.
of makes sense. So that got us thinking that the smallest unit of parallelism in Pinot today is a segment.
Hmm.
But now that we're not reading a segment at a time, not even thinking about going even beyond reading a column at a time, so could we even make that parallelism, the unit of parallelism, even smaller?
Yeah.
So for these two things mainly, we started thinking about some additional techniques. So one was start reading less. Uh, so here, kind of pruning techniques in Pinot. So there's like two stages where you can do this. One is
Yeah.
read lesser segments,
Hmm.
like the segments you need to access itself, kind of find the minimum subset in the first place.
Yeah.
And then the second is in that segment, read even lesser.
Okay.
So pruning techniques were already like a first-class citizen in Pinot. So we have pruning based on, say, min-max value of columns that we store
Hmm.
in metadata, or
Yeah.
if the data is partitioned, then partition info. And all this metadata was already cached locally in the new architecture, so we could
Yeah.
apply those. And then another very popular one is using Bloom filters.
Hmm.
So Bloom filter is kind of it's built within each segment, and it kind of quickly tells you if a particular value is going to be absent from your segment or not.
Yeah.
And this is more effective than the other pruning techniques. But then the problem was that it's inside the segment. So if you have
Hmm.
to read Bloom filter for all of the segments to decide which not to process, you've
Yeah.
already kind of, I mean, you're already doing that access.
Yeah.
So then here we came up with one technique. So far we only had configuration of, hey, less than so much days put locally, more than so many days put on the remote storage. We kind of took that one step further and said, hey, I want this specific column to be local, or the
Hmm.
specific index of this column to be local, and everything else on the remote storage.
Okay.
So with this, we were able to say, uh, like create Bloom filters for columns where you'll have filter predicates, and then say that, hey, I want to pin this Bloom filter locally.
Okay.
So, and Bloom filters tend to be like a very small fraction of size compared to
Yeah.
the all of your data. So with that, we were able to kind of very fast prune out a lot of segments that we don't need to process.
Hmm. Okay.
And then the more interesting part is the next part, where now that we have these segments, how do we read even lesser within those? So we were
Hmm.
doing the columnar fetch, but like, could we like do even better? So can we like make the unit of read even smaller than that?
Okay.
So for that, we're like still experimenting with this. Like we have some initial results which look like really promising. Uh, but we kind of started looking at the query in two parts. One is like the filter phase, and then one is the post filter phase.
Hmm.
So you can think of it as whatever you need in the filter phase, probably let's prefetch all that
Okay.
so that we can quickly apply the filter. But once you apply the filter, maybe you don't really need all of the column. Like very often your like especially if your filters are very selective, which very typically we have seen that they are, uh, like you might have like 50 million rows, but finally we were seeing that the num.doc scanned is like say in thousands. So we're
Hmm.
probably reading like a lot more than we need to.
Okay.
Uh, so we decided that in the post filter phase, let's not prefetch those entire columns.
Hmm.
Instead, on demand, when we once we have the results from the filter phase, that these are the matching documents, just read little chunks from that uh, entire forward index
Hmm.
instead of fetching the whole thing. And
Okay.
with that, we saw like a dramatic decrease in the amount of data fetched from S3.
Okay.
And that kind of immediately, since it was correlated with the 1.25 gigabytes per second,
Yeah.
immediately helped us bring the latencies down.
Hmm.
And then we didn't have to limit this just to post filter phase. Like even like let's say for the in filter phase, if you were to evaluate a filter, if you were reading an inverted index, you don't need all of the inverted index. You practically just need that one entry which
Yeah.
has that key that you're interested in.
Hmm.
So even there, we try to apply this technique of read just a specific chunk from that entire index, and we started seeing some amazing reduction in latency as
Okay.
well as the size read. Uh, and then we were thinking that so one of the observations after all this was that we were still not like it was really lesser compared to our baseline of just prefetch, but still it was not aligning with the 1.25 gigabytes per second. Like we were expecting that, hey, if now we're just reading a few megabytes, our latency should just like come down to like few milliseconds.
Yeah.
And the reason for that was the parallelism part. So since the smallest unit was a segment, and now that we're reading blocks within the segment, those all were kind of happening sequentially.
Mm-hmm.
So now we got on to thinking that, hey, could we uh, execute all those post filter chunks in parallel? Like, could we build some sort of a block level bloom filter or like an
Mm.
intra segment bloom filter that quickly tells us in the planning phase itself that these are the
Mm.
blocks that you need to go to.
Okay.
So now with the matching docs from the filter phase and now with these blocks that the pruner told us in the planning phase,
Yeah.
we are this is kind of where we're headed, where we're trying to uh, marry these techniques and get even lesser latency.
Awesome. Yeah, I think those are some of the really interesting techniques of optimizations, and I think you might have set like really high bar for you have to reduce the size of what we are fetching from S3, and that's what uh, helps you reach the even low data fetch and high performance. So I'm really interested in learning more on that. Uh, I think we have talked about how this works at a high level, and also what were the challenges you faced, and how things are done differently. What kind of optimizations you have done using Bloom filters at segment level and then at the block level as well, and that is very interesting. But what happens when things fail? What kind of failure modes exist when we talk about querying data from multiple tiers of storage?
Uh, so it's really like I would say there's nothing different compared to what you would expect in Pinot itself. The only thing that you're kind of adding now is the S3 component,
Yeah.
and so the additional failure mode is only as much as you would expect from S3, which is uh, pretty reliable, as
Yeah.
we know.
Yeah.
There's some things that we noticed during our stress testing, which we caught and fixed, and there might be more coming, but
Yeah.
things like we were seeing some throttling from S3 side
Hmm.
uh, because of, say, was it too many connections, or I don't think it was size of data, it was just like too many connections open or something of that sort.
Yeah.
So then we kind of had to dig up the S3 docs, and we stumbled upon using this async S3 client where it was keeping its own pool of HTTP connections and reusing them. So things like these. And then also just since it's kind of a new feature still in beta, we're still kind of figuring these out, ironing
Yeah.
out the chunks. Uh, One thing that could get a little cumbersome, and this is kind of going to be our next phase. So we went from making it work, we are now at making it fast. Next, we'll be at making it efficient.
Yeah.
So kind of making the operations of this easier. For example, if you can still do it today if you had to reindex all the data that's on S3, and but these kind of data evolution processes, we still need to do them. Uh, like we still rely on, as Pinot as a system, still relies on bringing the whole segment, massaging it and like, pushing it back. Like we can use techniques like some component like minion, which is like not in the query path.
Yeah.
But still, we are still figuring out how to start doing all of these more natively on S3 instead of falling back on basically the way we kind of had to correct assumptions in the query, we kind of have to take it all the way into all parts of like all
Yeah.
the various processes and parts of Pinot now.
Yeah, very interesting. So I think it basically you ended up touching like each and every part of the system just to make it more, natively support the tiered storage as a concept. Because
Yes.
otherwise it wouldn't have been, working so well as it is now. So what kind of testing do you typically do to validate that, first things are working correctly? Uh, it's not, giving some incorrect results. And also, I think you mentioned stress testing and performance testing. Can you
Yeah.
share some more ideas there? Like what things we should keep in mind while testing such a feature, which is so new and so fresh to the industry?
Hmm. That's a great question. So, we have a practice of taking even our testing in tiers, so to say. So
Nice.
we like have elaborate unit tests, of course, and then an
Yeah.
integration test with like a mock S3 and just like basic testing all the functionality with all like mock Pinot components. And then we have kind of a release certification test where like things get a lot more serious, where you have like real services deployed and uh, we already in Pinot have like this query, like rich query bank sort of that we,
Yeah.
whenever we get like a new feature, we just run through those queries and make sure
Hmm.
that we get the same results no matter what the change is. Like here
Yeah.
in this case, there's a new storage, there could be a new index, but like your results shouldn't change. What should just change is how fast or slow it comes or what
Yeah.
it's doing under the hood. So that elaborate kind of certification testing is something that we make it run through nightly. And then for the even more, like for the stress testing, especially, like all these tests done so far, like in the pipelines, used to be on like some smaller data sets, like gigabytes. But this is something that people would typically use only when they reach like terabytes, petabyte scale.
Hmm.
So we kind of had to make sure we run through that as well before we can hand it over to somebody.
Yeah.
So which is why we like our stress testing setup that we had was set with like several terabytes, I think a little over 10 terabytes for just 3 months. So it was like a pretty beefy data set. And we made sure to set all sorts of indexes that we have on it and uh, everything from like JSON index to range index, the different encoding techniques that we have. And after that, it was more about again running that same set of queries
Hmm.
through like a more systematic approach. We have like we try to do increasing QPS testing. We try to do like stable QPS for a prolonged period of time,
Okay.
and then we had some checks and balances to make sure that the memory that we are kind of allocating to execute locally is being released after each query, and
Hmm.
all the resources utilization is coming back down to zero, and like there's no leaks anywhere. So all those sort of things. And then after that, we kind of handpicked a few queries which we thought were interesting. For example, something that's trying to fetch a JSON index um, where
Okay.
which tend to be like really large columns with like really large indexes, or we picked something with just something that's fetching a lot of columns. So kind of we handpicked a
Hmm.
few of those and then uh, just like took it all the way with making sure we're observing the CPU utilization when we're running the test, watching the network saturation. That's how we got some of these issues that
Yeah.
led us to like the next round of optimizations.
Awesome. Yeah. Out of curiosity, I have two questions. I might be going a little back because you mentioned. So we use Bloom filters, and as I understand, they are like they have some false positivity rate as well, right? So if I understand correctly, if even if there is a false positive, that might end up having like an extra S3 call or read from S3, right? Or is there any other problem that we might face because of the way it works?
No, you pretty much pointed out the problem that can face with Bloom
Okay.
filters.
Okay.
The chance of false positives, which you can of course tune at the
Yeah.
expense of more storage for the
Yeah.
Bloom filters.
Yeah.
But that in combination with the in-filter documents that you get, and that in combination with the intra-segment Bloom filters that we plan to do,
Okay.
uh, should kind of help
Okay.
us
Yeah.
lower the overhead that we bear because of those false positives.
That makes sense. And do you also monitor these things? Like, what is the rate at which, the Bloom filter said that probably there is data here, but we did not find data. So, such things, do you also monitor? I'm just interested in, how the monitoring would look like here.
Right. I believe in Pinot, when we were fully local and tightly coupled, we did not do this
Hmm.
monitoring because like a few false positives was
Yeah.
still cheap
Yeah.
compared to like reading everything. It was still like a win. But that's a great point. With the new architecture, with like cloud native or decoupled support in Pinot, this is something that we would have to start uh, adding signals and monitoring on.
Okay. Awesome. And as a customer or as a user of Pinot, right? Can I move my data back from the cold storage to hot storage if I wanted to? And how would that look like in a, let's say, production cluster?
Yeah, so the configuration, at least for Pinot's tiered storage, is like it's in the Pinot table config.
Hmm.
Like you provide just like simple two things that say what's the segment age that you want to keep on local versus remote. So you can say
Hmm.
something like tier 1, 30 days older. And then you would provide the specs of what this tier is. Like you would say S3, this is the bucket, this is the region. Uh, and then Pinot automatically like keeps reading this periodically and moves it from the hot to the cold.
Okay.
And if you wanted to move it back in production, you would just like remove this or like make it some uh, 10,000 days or like simply remove the config and Pinot will just move it all back to your tier.
Hmm. Okay.
Uh, but you kind of have to orchestrate this carefully because
Yeah.
the assumptions, like your data may have ballooned up in that time, and now you have to make sure your tightly coupled
Hmm.
storage is able to handle all everything that you're putting back.
Okay. Interesting. And can I bring my own cold storage? Like, is it uh, I assume it is not tightly coupled with S3. It can also, support other blob storage, for example. Uh, are there, like, what kind of blob storages are supported as of now?
So, as of today, the implementation is only for S3, but
Okay.
it is only a matter of someone coming and writing the implementation
Mm,
for the new one.
yeah.
So, we do plan to, in the near future, start supporting GCS as well.
Okay. Nice.
So, yes, you can bring your own cloud storage. It should be like Pinot's architecture in general is very pluggable, so you should be able to come and just uh, plug in your own object
Awesome.
store.
Awesome. Uh, Great. What is the future of tiered storage? And, I mean, there is, of course, things that you're actively working on. But if we talk about, short-term future and really long-term, like 10 years down the line, do you
Hmm.
see some things, like some new things, interesting things coming up?
Yes. So, like you said, short-term future is the that read ahead, that the block level reads that we're planning, the
Hmm.
on-demand, smaller fetching, and the in parallelism things. Little long-term, maybe not 10 years, but say a few years down the line,
Yeah.
the way we have now added support for different types of storage.
Hmm.
We want to take this all the way to also being able to support different formats of storage. For example, most typically people have, say, Parquet files lying in S3. And then even with this tiered storage support, you still have to build a Pinot segment, push it
Mm-hmm.
to the Pinot cluster. What we envision is, hey, we should just be able to point to that bucket with the Parquet files, and Pinot should not care whether it was in the Pinot segment format or Parquet, and it should just
Mm-hmm.
work.
Okay.
So, kind of expanding to going beyond the Pinot segment format.
Okay.
So the way we kind of envision that is probably we will keep uh, like that is the source of truth data, and we just build the indexes or something like that. So this is kind of one
Nice.
idea where we want to take it. And then with that will also come the operational aspect of it, that doing this is fine, but this should not add an overhead of, okay, now you need this specific pipeline to kind of make sure Pinot understands this. So how to do this easily and
Yeah.
seamlessly. That's
Awesome.
kind of the that's kind of where we are headed eventually.
Awesome. Yeah, that sounds really great, and thanks a lot, Neha, for sharing all these details and in a such a simple manner that I could also understand. And you have made me more curious to go back and understand all these things into deeper context and read some blogs out there. I'm sure there are some blogs that people can read to know more about tier storage, how it is implemented, right?
Yes, there is one blog that we from StarTree released early this year.
Yeah,
That was kind of our initial, kind of like the phase one. It talks about, it stops at the part where we talked about that we did a benchmark with Presto, and
yeah.
these are our numbers. We kind of hoping to have another one out with all the follow-ups that we are planning pretty
Awesome.
soon.
Great. So I highly recommend people to whoever is interested in knowing more about Pinot and tiered storage. So go and read StarTree's blogs. They are really insightful. I I think I read one blog like why Pinot is so fast. I think it was called something like that, and that was so interesting. I think it was written by you, right?
Yes, what makes
Awesome.
Pinot fast?
Yeah. Yeah, so really great blogs there, so please check it out. And again, thanks a lot, Neha, for coming to the podcast. I think this episode is going to add a lot of value to people who are interested into knowing more about Apache Pinot, tiered storage, and also at a high level, like what kind of concepts and what kind of optimizations go behind implementing such a huge project. So I'm sure people would learn from this. And thanks a lot for doing the hard work on Pinot and making it possible to support tiered storage. And great, I really liked like talking to you about this concepts and really learned a lot from you. So thanks a lot.
It was really fun for me as well. Thank you so much for having me and giving me a platform to share what we're up to.
Awesome. Yeah, I'm surely looking forward to collaborate more on this as and more features are coming out. So I'm really interested in doing that. So thanks again, and have a nice day.
Thank you. You too.